Okay, we'll go ahead and get started. Once again, this is Matt Loxton with Cohesive. Thank you for joining today's educational series on Maximo. We try to do 2 webinars per quarter, providing the user community of Maximo information that we believe would be beneficial and that they can use to enhance Maximo within their own operation. So this is in that series of educational webinars, and this one's titled Reliability-Centered Maintenance Extensions for Maximo. The presenters today will be Lance Morris and John Reeve, who I'll introduce here in a minute. And I thought I'd just give you a quick basis for how Cohesive came up with this solution for reliability-centered maintenance. Through customer demand and through our own implementation experience, we saw a number of customers who were using third-party products to manage reliability-centered maintenance processes. And as a result of that demand and the fact that they wanted to begin to consolidate and shut down some of those third-party applications, we showed them a technique whereby they could use Maximo and the tools that are inherent within the product to actually support an RCM process. So the presenters today will, as I said, would be Lance Morris and John Reeves. Lance Morris is one of the co-founders of Cohesive and principal consultant focusing in on the work and asset management practice, and is also a solutions architect for the product. John Reeves has got a number of years around Maximo, dating back to PSDI, MRO, and has been around Maximo for years. He is a practice lead for advanced maintenance and scheduling processes. So with that, what I'd like to do is to turn it over to Lance Morris to begin the presentation.
Thanks, Matt. As you saw in your invitation to the webinar today, some of the things we'll try to cover is to demonstrate how to use Maximo to identify what equipment is important and why, identify how it fails and what are the resulting consequences of those failures occurring, and then what will we do to prevent or mitigate the risk of those failures, and then illustrate how to use it to capture feedback on the effectiveness of those processes and support a continuous improvement program. So RCM, what is it? Do I need it? Once I have it in place, is that it? If you ask 10 different people in the industry to define RCM, my experience tells me you'll get 10 different answers. If you ask most facilities if they have an RCM program, most will tell you yes, but the degree of RCM implementation will vary widely as much as the definitions would. So go ahead and click one more. So simply stated, if you boil RCM down, it really boils down to doing the right activities to the right assets at the right time. Now that's a lot easier said than done. It's hard to say you're ever finished with RCM because it is an optimizing process. So if you're not having any failures on critical or important assets, that begs the question, am I doing too much preventive maintenance? Or if I am having failures in those, am I not doing enough? So it's very hard to nail down and subjective as far as what the right time for the right activities to the right assets are. Okay. So some of the questions we considered when we began conceptualizing the RCM module in Maximo is, how do you know you're performing the right PMs and performing them at the right frequency? And what if maintenance personnel, the people who actually have their hands on the equipment doing the work, have information regarding that equipment that's not being captured and leveraged somehow in the system? And if it is being captured, is it in a textual format that's very hard to use the computer to leverage? And then what if we have missing foundation data, such as we don't have all our locations identified, all our assets, all our failure or problem codes? Or what if all our assets don't have a ranking as far as the criticality to the process or to the manufacturing systems. So some of the questions we've come across during our implementations is, some have said, you know, for years we have lots of good data, it's just in the heads of most of our staff, and most of them plan to retire soon. For some organizations, they capture the data, but it's in a textual format that's very hard to analyze and slice and dice from a computer perspective. And that presents a common misunderstanding by a lot of the maintenance organization that these text-only data is enough to support an ongoing process and a continuous improvement process. So when we started, the first thing we looked at is how do we identify the right assets that we should be doing work on. So one of the key things that we wanted to do is capture actionable data in addition to descriptive data. So you'll see we've added a lot of drop-down fields and standardized domain lists for people to select from so that we capture standardized data that's easy to leverage from a reporting as well as escalation and workflow process. So when we looked at assets and locations, we could have focused our view on either in this process. We chose to focus on the operating location, and part of the reasoning there is an asset is a piece of equipment that can move from one operating location to another. And as it moves, its criticality, the consequences of its failures can vary drastically, and that creates a data maintenance activity that has to occur every time we move an asset. So we chose to focus on an operating location, and an operating location not being a physical location, but an operating location as represented in a design diagram such as a P&ID or other type of design drawing for major components. That defines a component within the system or process that's needed to support the design, and then the asset is the equipment that we buy to meet those requirements and install in that operating location. Taking that approach, the criticality and consequences of failure are static based on the design of that operating location. So for an example, I could have a 10 horsepower motor, and I could have two of the same manufacturer model motors. One is installed on to drive a pump that feeds lube oil to a bearing on a critical pump in the system, and the other might be a feed to run a lift pump for a bathroom that's out at the intake structure. So both are the exact same pieces of equipment, but they have drastically different criticalities and failure consequences. So when we looked at the,
Sorry.
A little fast.
My bad.
When we looked at the operating location, we said, what information do we need to capture? So we wanted to capture what the design function of the operating location is. What is it supposed to do in the process if it's meeting its design requirements? How critical is that operating location to the process? In that case, we tried to keep it somewhat simple, so we've only identified 3 levels of criticality so far as being critical, important, and run to failure. Being a standard domain in Maximo, you could add as many as you need. Then we looked at how does it fail and what are the consequences of those failures occurring, and how do we capture that data. And then what other considerations about the operating location might affect the performance of the equipment. Might shorten its life or might increase the frequency for the need of preventive maintenance to be done. Then we looked at, once we have those failure and consequences identified, how are we going to mitigate or prevent those risks from occurring? Most risks can be mitigated by preventative predictive maintenance as scheduled by Maximo. So within that preventive maintenance or predictive maintenance program, we wanted to be able to capture what the basis of that preventive maintenance strategy is and the basis for its frequency. We wanted to capture what risks that PM is intended to address to kind of close the loop and say what failure modes is this particular PM intended to prevent or mitigate. And then how does that PM specifically address that failure mode? So we wanted to capture all that information within the Maximo framework. So this is an example of how we might establish a maintenance strategy using standard methods. And I'll let John speak to this a little bit.
Good morning or good afternoon, depending upon where you are. The point on this slide here is that failure modes effects analysis, that is the FMEA acronym, is a standard methodology that can be implemented in any organization, any site. There is a level of effort associated with that, and there, of course, can be a cost. We're saying that's still appropriate to perform. However, we are also emphasizing that you as a EAM system or Maximo user this very moment can utilize the base product with some minor modifications to immediately enhance your failure analysis process and, of course, asset performance. And we'll get to those details very shortly. Thank you.
All right, for the RCM extension, we have not built any new applications within Maximo, but have made alterations or added tabs to existing applications. This has all been done with standard tools that come with Maximo: application designer, database configuration, domains, escalations, notifications, and workflows. So there's no customization or no Java coding that's been done to affect any of this, which makes it such that it should be easily upgradable from one version to next. So kind of going through the process on the locations application, since we took the approach from an operating locations perspective, we've added a tab for RCM to capture the detailed failure modes and effects analysis. We've also added another tab for a more streamlined approach, which we'll discuss as we go through the presentation. To support that streamlined approach, we've made some changes to the master PM application. And then on the main PM application, we've also added an RCM tab to capture some of the information that we were talking about earlier. And to help leverage some of that information, we also added a work orders tab to the PM application to allow you to quickly view trends of how the PMs have been operating in the field and what the feedbacks were. Then on the work order application itself, we've added tabs to capture RCM feedback as well as other types of feedback. And we'll talk about how you might leverage many different types of feedback within a work order application. But we did break it down in our example for today by corrective maintenance as well as preventive maintenance, and showed the different types of feedback that you might want to capture in those situations. Okay. So this is a screenshot from the locations RCM tab for the detailed failure mode and effects analysis. So you can see up in the upper panel where we've added a text field to capture the design function for the operating location. Again, that goes back to the question of what is the location intended to do to support the process. We've leveraged the existing failure class that was on the locations application. We've also tried to go ahead and leverage the priority field that was on the location application, relabeling it as criticality. You could easily create your own criticality field as well if you used the priority field for something else in the past. As far as conditions that might affect the preventive maintenance strategy, we added a couple of fields for environment, what type of environment the location is installed in, whether it's indoors, outdoors, whether it's in a protected environment or not, and as far as our corrosive environment. As far as the duty cycle, whether the equipment runs continuously or rotates, maybe you have 3 pumps but only 2 are required and they run in a rotation, so that affects the eventual planned runtime on the equipment and might affect your maintenance schedules. Down in the center portion of the screen is where we capture the detailed failure modes and effects analysis. So we've leveraged the Maximo failure code hierarchy in this case and have exposed the problem codes that are associated with the failure class. Then for each problem code that that may apply to this operating location, we've added additional fields to capture to identify whether that problem code represents a functional failure for that component, whether it's related to personnel safety or it might be related to environmental protection. All those may affect the priority of the maintenance strategies or PMs that we do. And then over on the right, we've added a text field to capture the consequences of what happens to the process when this failure occurs. We also added a couple other fields just to help out in prioritization of PMs in the future. One is economic impact to production. You may have a failure that causes a large economic impact to production that may affect your maintenance strategies. And then you may also have an economic impact to repair. It may not, the failure may not affect the process, but it may be very expensive to repair and therefore justify preventive maintenance activities to prevent it from occurring. So we tried to capture all that in the detailed FMEA table window, and I'll come back to that bottom section in a couple of slides. Next. So now I'm going to jump over to the PM application, and as I mentioned a couple of slides ago, we added a RCM tab to the PM application. Within that, we've added a couple of text fields to capture the basis for why we're doing the PM, as well as the basis for why we're doing the PM at the frequency that we've scheduled it at. Then down in that bottom table window, similar to on the locations, we've identified which problem codes or failure modes this PM is intended to either mitigate or prevent from occurring. And in the process, we've added another description field over to the right that defines how this PM is intended to prevent that failure mode from occurring. And we'll leverage all this information when we get back to the work order feedback in a little while. Next. As I mentioned, we would come back to that location, RCM, failure modes and effects analysis tab. And now what I wanted to show is now that when you select a given failure mode in that center table window, the bottom table window will populate and show you all the PMs that you're currently doing that are tied to that failure mode. So in effect, it shows you your maintenance strategy for mitigating or preventing that failure mode from occurring. So if this were a live system and we click the low pressure failure mode, you would see a different set of PMs populate at the bottom that are tied specifically to the low pressure failure mode. So as we went along, we realized that not all customers will want to do a detailed failure modes and effects analysis on all their operating locations. So we wanted to, in the center window, just gives you an example there of what all might be involved in performing a detailed failure modes and effects analysis. And you can imagine in a typical power plant where we implement Maximo, we might have upwards of 30,000 operating locations for a given unit. And history tells us that more often than not, less than 20% of those locations actually have work orders ever written against them. So why would we do that detailed analysis on the 24,000 operating locations that we're never going to work on? So we had to come up with a way of capturing meaningful data at an equipment type level as a starting point for building strategies across large chunks of equipment without having to go to the detailed analysis. So depending on where you are in your maintenance maturity as far as implementing an RCM program, this can be one strategy that provides a quick return on investment by attacking large chunks of data. And then using the techniques we'll talk about in a little while, you can leverage Maximo to help you grow into a more detailed failure modes and effects analysis where appropriate. Next. So as I mentioned, as far as the applications that we enhanced to support the streamlined process, we've enhanced the master PM application. So you can see over on the upper right-hand corner where we've added the failure class as well as the criticality code, environment, and duty cycle to the master PM application. We also added another table window at the bottom similar to the PM application to identify which failure modes are addressed by this particular PM. Now, one caveat that I will offer up as far as using master PMs is master PMs do require system level job plans. So if your implementation of Maximo involves multi-site, multi-org, in order to identify a job plan for a given master PM, it has to be a job plan that is not organization or system or site specific. It can still have organization or site specific tasks that would roll into those individual organizations' work orders, but the job plan itself has to be a system level. All right, next. So now we're back on the locations application again. This is a different tab that we've added called RCM Streamlined. And what we've done here now is we still have that design function that we saw on the FMEA tab. And we also have our failure class, criticality, environment, and duty cycle. And what we've set up is once you define the failure class, criticality, environment, and duty cycle for a given location through a Maximo relationship or a predefined join, this center table window now populates with the recommended maintenance strategy for that type of equipment under those types of conditions. So it goes out and pulls all those master PMs that have that same criteria and lists them out as the recommended PMs for this operating location. Then down in the bottom table window, we're displaying the actual PMs for this operating location, as well as which master PM those PMs are tied to. So you can quickly get a view as far as how you are adhering to the recommended maintenance strategies. This also gives you what we call that, go back to that word, actionable data, in that now I can use the computer to look for anomalies where I'm not adhering or have veered from my recommended maintenance strategy and push those to individuals that may need to resolve it or use it as reports on my maintenance strategy adherence. The other advantage of the streamlined option as well is looking at it from a corporate or global standard. You know, once I start gathering all my data from Maximo for failure histories and PM as found conditions, let's say down at that bottom master PM, I'm scheduled to do my pump overhaul once every 4 years. And based on the as found condition of the equipment and the failure modes that it's tied to, I haven't seen any of those failure modes. The as found condition of the equipment is pristine when they open it up to do the overhaul. So I might want to extend that frequency from 4 years to 6 years. Well, now I can do that at the master PM level and use the master PM to push that change out to all my implementing PMs without having to go and modify each of the individual PMs tied to that master PM. So that is some of the master PM functionality that can be leveraged in this streamlined option. So again, very important to the process. We wanted to capture data to monitor and provide continuous improvement. So we wanted to capture the data from a work order and get as much data as we could from the people that actually have their hands on the equipment and actually capture it in a way that we can leverage the computer to help us look for anomalies and push the things that need to be reviewed and resolved to the individuals that need to do that work. Also, we wanted to build in some accountability to the process. If people provide that feedback, they want to know that it's being used and leveraged. Otherwise, they'll quit supporting the process. So we wanted to build in the ability to have accountability. And as I mentioned, the work order process supports continuous improvement. So as I mentioned early on, work order feedback can be applied to corrective or preventive maintenance. These are some of the examples of the different types of feedback that you could capture from a work order perspective. So you're looking at your overall strategy for maintaining the asset. Is the frequency the right frequency? Looking at the condition of the asset when you're going to perform the corrective maintenance or preventive maintenance, trending that what the condition is, looking for suggestions for design issues, safety or environmental issues, maintainability for access, failure problem codes. We may need new failure codes. We may need to create new assets to further break down components into more manageable, maintainable units. And then tips for reducing future breakdowns. They may have ideas for new PMs that might be able to prevent future failures. And then we're also looking at validating our estimates and do we have the right tasks and steps and permits and documents needed to support the strategy as well as the work orders going to the field. So we can capture all that different information in actionable data and push that using Maximo tools to the different individuals that may need to act upon it. So it may, as I mentioned, it could involve personnel safety. Maybe it needs to go to the safety manager. It could involve enhancements or changes to design for maintainability, which could involve the maintenance and the engineering manager. It could be the way that they operate the equipment is affecting the life of the equipment. So that may go to the operations managers for changes to the operations procedures. And all that gets captured and that feedback managed within Maximo, so you have one-stop accountability within the system. There's many different ways we can leverage Maximo for the routing of the information. We'll talk about a few using either workflow or escalations with notifications. And then you could even set up, in some cases we've set up specific feedback objects within Maximo that are basically child objects of the work order that can be managed and workflowed on their own outside of the work order to manage other design change or activities that may be needed to support the maintainability of the equipment. This is a screenshot from the work order. We have added an RCM tab to the work order completion main tab. That RCM tab has two sub-tabs. The first one we're looking at here is the corrective maintenance sub-tab. Within that now we're leveraging that design function that we entered earlier on the operating location application. So we're displaying that here to the person providing this feedback so they understand what the location was intended to do from a design perspective. In this case, this example of feedback, we're trying to determine if this was a maintenance preventable functional failure, and if so, what we could do to prevent it. But we try to do that in logical, easy questions. So we ask the question, did the location fail to fulfill its function? With a drop down of yes or no. Was the failure preventable? Drop down yes or no. And what could have been done to prevent the failure in a text format. So again, using Maximo 7, now with the conditional UI, we can actually hide this tab unless it's needed. So in the case of a preventive maintenance work order where the PM num is not null, we could hide this tab, or if this work order is written against a run to failure location, then corrective maintenance is the expected outcome of that. So it's not necessary to capture this feedback in that situation because we got what we expected. Next. This is a screenshot from the PM subtab, and again, using the configurable UI, we could hide this tab unless the PM num is not null and the work order came from a PM itself. But similar to the corrective now, we're leveraging some of the extra information that we added to the PM application. So for information, we're displaying the basis for why we're doing the PM, the basis for why we're doing it at the frequency that we're doing it. And then we tried to capture logical data as far as what the as-found condition of the equipment was in. So we give it a numerical rating with descriptions for those numbers as far as whether the equipment was in great condition or whether it was okay but needed adjustment. So we give it a grading level to capture the as-found. And then we ask simple questions about, was the PM effective? Was the frequency adequate? And what could we do to enhance it? And then again, as further information, if you remember on the PM application down at the bottom of the RCM tab, we added the failure modes that the PM was intended to prevent or mitigate, as well as a description of how that PM was intended to act upon that failure mode. So we've displayed that information at the bottom as well as additional information when evaluating the effectiveness of the PM. As I mentioned, in which applications we enhanced on the PM application, we also added a work order tab, and the purpose of that was to use built-in Maximo relationships to display a work history for this given PM, and it allows you to quickly look in that bottom table window and kind of see a trend of what the as-found condition of the equipment was in when the PMs were performed. So it gives you a quick and easy spot to see were there PMs that were skipped, what was the condition of the equipment, is it trending up, is it trending down, it gives you a quick and easy way to do analysis on the PM to evaluate its effectiveness and any changes that might be needed. So again, using standard Maximo tools, basically escalations, now that we've got actionable data in the system, we can create escalations to look for things that need follow-up and then use either workflow, simple workflows, or notifications through emails to automate that review process and leverage that data. So some examples, we can use that feedback to help build out those missing foundational data, whether it be failure codes or criticality codes. We can use this process to track and act on feedback. We can also use it to look for anomalies where our maintenance strategy may not be as effective as we would hope it would be. Next. So this is an example of Start Center, and in the examples we built out, we used workflows, simple workflows for routing those things that needed follow-up. So you can see an inbox with messages from workflow, and these might be for multiple different individuals within the organization. We put them in one to simplify things. So the next slide, we have a larger view of that. So what you see highlighted in the middle now is how we've leveraged it to build foundational data. So these are two work orders, corrective maintenance work orders that were written against operating locations, but those operating locations have not had a criticality code defined for them yet. So now they've been pushed to a reliability or maintenance engineer to define what their criticality is to the process based on the definitions and procedures. The two highlighted at the top now is as we build out our failure modes and effects analysis with consequences of those failure modes occurring, these are two corrective maintenance work orders that were written against locations that were either identified as critical or important. and the work order identified a problem code that has not been analyzed in the FMEA table window on the location. So again, it's pushing us to build more foundational data. So you could use this type of strategy if you started with a streamlined approach and then wanted to go to a more detailed approach for, say, your critical locations. You could have those pushed as corrective maintenance work orders are done, identifying those failure modes, identify what the consequences and maintenance strategies are for those. The green one highlighted now shows an example of where we do have a detailed failure modes and effects analysis done for the low volume failure mode. It is also tied to PMs, which are intended to prevent or mitigate this failure mode from occurring. However, we did get a corrective maintenance work order against a important or critical location that identified that failure mode. So now this is being pushed to say your maintenance strategy did not prevent this failure mode as expected. So now we go to evaluate what went wrong with our maintenance strategy. Is the frequency incorrect? Did we have the wrong procedures? Did we skip a performance? So depending on the level of criticality of the location, you could have, this might create a root cause analysis if it's a functional failure mode on a critical location. And then lastly, down at the bottom, as people provide suggestions on how to improve PM, a given PM, we're pushing that to the Start Center through a simple workflow as well. So these identifies work orders that added comments related to how a PM could be improved on that PM feedback tab of the work order. This is an example. We used workflows in that inbox in the previous slide. You could just as easily, with the escalations, have them create email communications using Maximo communication templates. The emails can be pre-formatted using data from the work orders. And then you can also check the box for the communication log entry so that the email becomes part of the work order history on the log tab under the communication subtab. And now I'll let John address the next few slides.
This is the illustration picture showing the entire process, beginning with new work coming into the system. That work, depending upon its priority in urgency, would get planned and scheduled. The work eventually in the backlog gets placed in progress, and actual hours are reported, perhaps actual materials, etc. The work is completed. Now, it is during this completion phase when the data, in this case feedback, is very important that we get from the trades. And the RCM extension here that we're discussing helps automate that data capture, review, refinement process. Give me a click on that, Matt. Now, one of the points we're making is that a simple Pareto analysis can provide significant improvements, and so with this data being captured, we can perform trending on problem codes, recurring breakdowns, and then drill down in that manner. That's at the micro level for one site, one plant. And of course, if an organization has multiple sites, you can do comparisons, which is utilizing this normalized data across the enterprise. That's good, Matt. Thank you. On this slide here, let's be honest. We are talking about additional time by the trades or maintenance, other maintenance staff to enter this data. But what I want to emphasize is that valuable data is out there in the minds and heads, perhaps tribal knowledge within the trades, and it's important that we capture this information regarding asset performance, and we can capture this today. It's really just a decision on your part the organization leadership team to implement that particular process. You know, we've also heard and read many articles today where industries are complaining about aging workforce, and there's no sense waiting till the 11th hour, like next week your maintenance supervisor is going to retire. Let's start thinking ahead and capturing this information right now. And so again, the ideal method is to implement a process of updates, and we're calling this work order feedback. Now, in this case here, I'm trying to illustrate graphically between the two red lines with a little additional time. We're suggesting maybe 5 minutes per individual. This work order feedback can be properly captured, and then we'll provide substantial information to help you make more informed decisions regarding reliability-centered maintenance. And we'll show that here shortly. So to wrap up, Lance, I'll let you take this here and summarize.
So again, the goals were to capture information to improve equipment reliability. So again, based on our background and experience, most people that do have some sort of RCM program have it separate from their maintenance and asset management systems, although they're very dependent on one another. So in order to do the RCM analysis, you need the maintenance histories and failure codes and assets and locations that exist in Maximo to develop your maintenance strategies, which then get implemented as PMs in Maximo. So we tried to set up foundational properties within Maximo to capture the data in one system so that we could automate those reviews and push the work items to the people that need them. Okay.
It's important to understand the end game. An effective PM program enhanced with reliability-centered maintenance can help your organization avoid substantial costs associated with unplanned breakdowns and emergency repairs, not to mention that knowledge that aging workforce walking out the door at retirement. So here we have 3 boxes in color, blue, pink, and yellow. The failure analysis is where I want to focus, and the key boxes there are the RCM work order feedback in the top center, which is the key design of our RCM extension, and then organizationally, some industries will have a reliability team to help process that data. That's good, Matt. This is another summary picture showing what we call the ideal model, and there's 3 significant strategies here I want to point out. The PM work order feedback at the bottom of this picture, where it shows actual hours, delay codes, but specifically the feedback portion, that's where the process starts. It comes up there, it gets reviewed by the reliability team. They also may assign action in the case of failure analysis. You know, somebody has to do something with this data, and so it's important to have actions assigned. And then on the far right, there's another methodology which we're not going to discuss today, but we refer to this as a roadmap adjustment. It's a business process review, which is done on maybe every 5-year basis. But the combination of those 3 strategies can help any organization become world-class. Thanks, Matt. Now maybe go ahead, Lance.
We talked about a lot of the foundational data being able to support better reporting. These are just some examples of what you can leverage this data for now. One specific example I would point out is, most industries, most plants will monitor corrective maintenance backlog. But now with location criticality codes, you can not only monitor that backlog, but monitor the quality of that backlog. So what % of your corrective maintenance backlog is on run-to-failure assets? Those are run-to-failure locations. Those are expected conditions. And what % are against critical or important locations, and why aren't we doing something to prevent those if that is the case. So now you can view these in a different light with just some minor additional data.
If I could quickly add,
Sure.
There is no report which can't be written. It really comes down to your imagination, but the first step is to gather the data. Now, we've been mentioning throughout this presentation words called actionable data. And with that data in our left hand, we can now run an SQL statement to help us generate some of these reports. Also quickly, if you remember one of the slides Lance mentioned, the fields were economic impact to production and economic impact to repair. And imagine the value of that data when sliced and diced. The last point I would make is if you had a mobile solution technology that can be laid on top of this design and also enhance the ability of the field to directly perform these updates. Thank you, Lance.
Well, Lance and John, thank you very much for that. And I would like to now, I'll open up this control panel on my side. And what we'll do now is have a little bit of time. We've got about 10 minutes left for question and answer. So everybody was on mute. It's just the way this GoToMeeting session works. If you have a question, there's a couple of ways to get it to us. One, you could put something in the chat window. The other way is to raise your hand. And if you're connected through audio the right way, it will be unmuted. And we'll respond over the phone. If you do type something in the chat and we're unable to get to it, it will come to us in a spreadsheet form, and we can respond that way following this session. This session is also recorded so that if you have a desire to have it to share with others in your facility, we can certainly make that available to you by passing a URL your way. So what I'll do now is open it up for questions. If you have a question, just go ahead and raise your hand. See if we have any questions. Okay, we have one from, looks like Marianne Foster. Marianne, go ahead. Marianne? Marianne?
Can you hear me?
Yes, go right ahead.
Oh, okay, cool. My company would be very interested in having a copy of this to share with our team.
Okay.
Is that possible?
Yes, we'll be glad to share that.
Okay, you want me to type my email address in here for you?
I think we'll have it.
Okay, great, perfect.
Any question other than that, Marianne?
No, it was very informative. I liked it a lot.
Okay.
Thank you.
Thank you for your comment.
Oh, no.
Go ahead.
No. Gotta look at travel again?
Okay, we have one from, let's see, I can go ahead and put Marianne. Okay, thank you. And then it looks like Ruben Ortez. Ruben, go ahead with your question. Maybe Ruben's okay. Okay, we'll move on. Okay, anyone, if there are any other questions, go ahead, last chance to raise your hand. It looks like Ruben's went back up. We'll try him again. Ruben, go ahead with your question. Okay. All right. Well, I'll just, let's see. It looks like Joe Davis has a question. Joe, go ahead. Could be people are inadvertently raising their hands. If for some reason you're trying to say something and it's not coming through, just go ahead and type it in the chat window. Okay, Joe, I see your comment that you're unable to speak. Again, you can either type a message in here, or if it's too lengthy, you want to email it to us, or you can always call me at 770-378-5402, and I'll answer it that way. I'm sorry you're having trouble with your audio.
Man, I think there's one more slide with some contact information as well. If they do have further questions or wanted to send a question privately, they could use that method as well.
So thank you, Lance. So what you see here is as Lance said, you can send us an email to sales@cohesivesolutions.com or call that number, or the one I just read off to you. Also, you may want to note that link, and again, it'll be in this presentation, which we can make available to you. But that link goes to our website, which provides a work order feedback document and brochure talking about the RCM solution and the work order feedback loop. Again, I'll say this: making these changes to Maximo is a relatively easy process. We've used tools that are inherent that are part of the product. They're included with Maximo, as many of you know, with Application Designer, workflow, escalations, communication templates, and whatnot. The more challenging effort here is actually moving an organization from a reactive maintenance approach to proactive, and maturing your maintenance model to enforcing a process and a rigor to accurately capture data that is actionable to support an RCM process. So thank you for joining, and we'll conclude the webinar at this time. Please look forward to keep an eye out for future announcements on future educational sessions from Cohesive. Thank you.